All right, let's talk a little bit about, let's take water, for example, and we're going to have some axes here. Maybe one axis that goes this direction, and of course one that goes this direction. Okay. Let's go down here so I have room. So let's say that we have water, and let's say that the water, get black here, let's say the water starts out at right here, and let's say right here is negative 40. So basically what we're going to have here on the y-axis is temperature in degrees Celsius, and we're going to have, we have a lot of things down here. We could have energy. Let's put energy here. We also have time in joules. Now none of this is going to be drawn to scale since I put energy down there. But let's say that we start out at 20 degrees. Let me make a few more marks on here. We're going to make this 0 degrees. So this is negative 20. This is negative 20 degrees. And then here will be 100 degrees. And then here it'll be 120 degrees. So we're going to get our frozen water, which we call ice, and we're going to start heating it up. Now, ice can be colder than 0, right? So it's going to take off like this until it gets to 0. At that point, there's going to no longer be a temperature rise, and it's going to be a constant temperature for a little bit until all of it's melted. Then it's going to take off again, and it's going to heat up, heat up, heat up until it gets to 100. Once it gets to 100, again, it's not going to, temperature's not going to change anymore. And once all of it's boiled away in its steam, then the steam will just continue heating up as long as we add heat to it. So, let's see here. So this down here, this would be a solid. This would be a liquid, and this would be a gas. In the case of water, that would be ice, water, and steam is what we would call it. This part right here is where it melts, and this part here is where it boils. So we're going to call this part right here part A, part B, part C, part D, and part E. So as I add heat to this frozen water, the ice, it begins to heat up. Well, how do we find the heat for part A? Well, it's going to be QA, that's the heat for part A, is going to equal mass of the ice, which is going to be the same as the mass of the water, times C of the ice, so you look that up, times delta T. That is the heat added for the ice. Then what happens at B? How much heat do I add at B? Well, there's no temperature change, you'll notice. So the heat added at B is equal to the mass of the ice and the water together. It's still the same, it's just melting, times what we call the heat of fusion, the latent heat of fusion. I guess we could call that HF. I forget what your book calls it. We call that for the latent heat of fusion. No temperature change, that's a number. HF is a number you look up. Masses of ice is, or mass is the mass of the water and ice you have. All right. Then I keep adding heat. How much heat do I have to add to part C? Okay. We are now liquid, or water. We're liquid, so it's going to be mass of the water times C of water. You can look that up. It's 4186 joules per kilogram degree Celsius, I believe. times delta T, the change in T. So the change in T here would be 0 minus 20, so it would be positive 20. The change in temperature here would be 100. And C is something we would look up, and M is the mass. All right? Then how do we find how much heat I have to add at D? Now I want you to notice the heat added at part D is much more. There's a lot more energy that you have to add to boil the water than to melt it. And that's true. Steam to change water from liquid to a gas takes a lot more energy than it does to melt it. And so that was just going to be M, the mass, times the heat of what we call the heat of vaporization. That's another number you look up. All right? And then the last part, however hot we're going to heat it up, let's say we go to 120, then the heat added at E is going to be M C of steam, so this is going to be steam, times delta T, which in this case would be 20 degrees. And so if we wanted to know the total heat added to get it from negative 20 all the way to 120, we would add all those numbers together. And again, these numbers are not hard to get because we look up, I'm going to circle the ones you can just look up. I mean, that one is a number you look up in the table. Sorry, excuse me, this one is, okay, let me get that pin again. So lose my mouse quit on me for a second. This one's one you look up in a table. This one's one you look up in a table. This one's one you look up in a table. And this one's one you look up. So you just look those up. They're not mysterious. Mass is whatever you start out with. So if you start out with 100 grams of ice, which would be 0.1 kilograms, everything has to be an SI. And then you know the temperature changes because we're going to have a temperature change here of 20, temperature change here of 100, and a temperature change here of 20. And so you know all the temperature changes, and you just got to look up the constants. You add them all together and you get the total energy added by adding up these 1, 2, 3, 4, 5 different numbers you get. And that's how you do a problem like this, and this is in kind of an overview of this chapter on heat and liquids and solids.